All right, so last time we dove into Sabre, the system that pretty much invented real-time airline reservations. But here's the thing. As air travel exploded in the 1970s, Sabre and systems just like it, they hit a wall, a massive wall. Real-time access just wasn't enough anymore. They needed a whole new kind of power, a real engine to drive the entire operation.
And that's exactly the right way to think about it. The problem was no longer about the flight controls, the cockpit. It was about raw, brute force power. The kind of power you need to get a gigantic global industry off the ground. And the answer? Well, it was a system you've probably never even heard of, but trust me, it changed absolutely everything. It was called TPF.
So let's just picture the 1970s for a second. Flying is becoming a thing for everyone. It's just exploding. And suddenly, the big challenge isn't just about giving one travel agent access to one flight. Nope. Now it's about somehow managing this colossal tidal wave of information flooding in from every corner of the globe every single second of the day.
I mean, we are talking about a true data deluge here. You've got millions of passengers trying to book seats, thousands of flights crisscrossing the skies, and all this data is pouring in from hundreds and hundreds of terminals. This wasn't just a stream of data anymore, it was a tsunami.
And this slide, this nails the difference perfectly. The first big hurdle was all about access, getting that information in real time. But this new crisis was all about throughput, just pure, raw capacity. How do you shove an unbelievable number of transactions through the system without the whole thing just grinding to a halt?
And the technology they had back then just wasn't cut out for the job. Your traditional databases, with all their complicated structures and rules, were just way too slow, way too inflexible to handle this kind of insane demand. The industry was really teetering on the brink. They needed a totally new way of thinking.
And that new way of thinking, that radical answer, came from IBM. And it wasn't just some faster database or a simple upgrade. This was a purpose-built transaction engine designed from the ground up to solve this one single massive problem of throughput. And here's the kicker, the thing that might just blow your mind. When we think about handling massive amounts of data, our brains immediately go to database. But TPF, it wasn't a database at all, not even close. It was what you call a transaction processing facility. So think of it less like a quiet library where you carefully store and retrieve books. Think of it more like the central sorting hub for a global shipping company at peak season. Its one and only job was to process a ridiculous volume of transactions at blinding speed. That's it.
So the big question is, how did it do it, right? How did TPF pull off what seemed impossible for every other system? Well, the genius was all in its architecture. It basically took the old rulebook for data management and just threw it out the window in the name of pure, unadulterated speed.
Okay, so here's the secret sauce. Instead of those complex, interconnected relational tables, TPF used super simple, super efficient flat files. It kept all the most important data right there in the computer's main memory for instant access. And, this is the big one, it totally sacrificed flexibility for speed. It did one thing, and it was designed to do that one thing faster than anything else on Earth.
And the result of all that focus? TPF could handle thousands of transactions every single second. Now, this wasn't just a little bit better. This was a quantum leap. It was a complete game changer that left all the other systems choking in its dust. And that speed, it mattered more than you can imagine. For a travel agent with a customer on the phone, or a bank teller with a line out the door, waiting even a couple of seconds is an eternity. It's just not acceptable. TPF delivered sub-second response times. That was the holy grail.
So with that kind of incredible performance, is it any wonder that TPF became the invisible backbone of the entire airline industry? It was the engine running everything behind the scenes, from booking your flight and checking your bag to scheduling the flight crews.
And you had all the big players jumping on board. We're talking American Airlines, British Airways, Lufthansa, you name a major airline, and chances are they came to depend on TPF's legendary speed and its rock-solid ability to just run and never go down.
But the story doesn't end there. TPF wasn't just some flash in the pan. Its legacy is just incredible. We're talking decades of unparalleled performance and a reputation for being absolutely bulletproof.
I mean, just look at this journey.
It's born in the 70s out of a crisis. It spends the next 20 years completely dominating the industry. In the 2000s, it evolves into its modern successor, ZTPF. And get this, it is still running at the core of critical systems today on IBM mainframes. In the world of tech, that kind of lifespan is almost unheard of.
Now, of course, nothing's perfect, right? That long legacy comes with some trade-offs. On the one hand, you have a system that is insanely fast, reliable, and absolutely battle-tested. But on the other, all that specialization makes it really hard to modernize. What a lot of companies do today is they kind of wrap these old TPF systems with modern APIs, creating this hybrid architecture to get the best of both worlds. And really, if there's one big lesson to pull from the whole story of TPF, this is it. Real, massive scale isn't just about how much data you can cram onto a disk. It's about speed, it's about reliability, and it's about the fundamental architectural choices you make from day one to achieve that.
Which leaves us with one final thought to chew on. TPF is a true unsung hero, a specialized tool built to solve a specific, massive problem, and it did it brilliantly. So as we all rush to build the next new shiny thing, you have to ask yourself, what are the lessons from these old-school powerhouses that we're in danger of forgetting? What about that focus on speed, reliability, and purpose-built design? It's definitely something to think about.